Alright, so in this video we're going to be looking at integration by parts. Right. So integration by part has a general formula of u dv is equal to uv minus the integral of v du. So what's left for you is to determine in an integral that which one is u and which one are you using as dv, basically, right? Because let's say you have an integral of x e to the power of x dx, right? So you have to now determine which one is x, which one is going to be u, and which one is going to be v, right? So for this one now, x is u and your ex is dv, right? So you are doing it like this, right? Because this is like the formula. So for this to be the formula, then this one in this question has to take the form of this, right? So x is u and dv is e to the power of x. So you're going to say u is equal to x, I'm going to say dv is equal to e to the power of x dx, right? You can choose to omit this one because it's symmetric to save time, right? So what you're going to do is that you're going to find the derivative of this side, but you're going to find the integral of this side, right? So here you're going to say du dx, and this is going to be give us 1, but here you're going to take the integral of dv, and I'm going to take the integral of ex dx. All right, so here now you're going to make the du subject of the relation. So you're going to say du is equal to dx. Here, when you find the integral of dv, you just get v, right? And this is going to be equal to e to the power of x, right? The integral of e to the power of x is e to the power of x, right? So now that you have this, then you can now apply this formula, right? So we're saying that u dv is equal to uv minus the integral of v du, right? So now our u is what? Our u is x, so we're going to put it x into the bracket of v. V is what? E to the power of x. Then we have minus the integral of v. V is what? E to the power of x, right? Then we add du, but du is what? Dx. So right, so we put dx. So here now our final answer is going to be x e to the power of x minus the integral of e to the power of x is what? E to the power of x. Then we add plus c because it's integration. So you can leave your answer like this, or further simplify, you bring e to the power of x out, then you have x minus 1. So this is your final answer for this question, plus c. So this is your final answer for this question, right? So let's take another one. So now let's say we have a question such as this. E to the power of x sine x, then we have dx, the integral of this, right? So now, just like we did here, we have to first express it in the form of u dv, right? So one of them is going to be u and the other is going to be dv. So this one, e to the power of x will be u and dv is going to be sine x dx, right? So we'll say u is equal to e to the power of x, and we have dv to be equal to sine x dx, right? So now we find the derivative of this side and we find the integral of this side. So we have du dx to be equal to e to the power of x, and here we have the integral of dv to be equal to the integral of sine dx, right? So here we'll make du subject of the relation. So we have ex dx, and here we have v is equal to the integral of, so this was to be sine x. The integral of sine x is going to be minus cos x, right? So we have this. So now applying our formula, we have uv minus the integral of v du, right? So our u is what? E to the power of x multiplied by v, which is minus cos x. Then we have minus the integral of v, which is minus cos x. Then u, we have du, but du here is what? Ex dx, right? So we're going to have ex dx. Now we have negative here, we have negative here, they will multiply and that will give us positive, right? So we have minus ex cos x plus the integral of cos ex dx. It's not cos ex dx, sorry, ex cos x. So let me just clear this. The integral of ex cos x dx, right? So we have that. So now as you can see now, we have to now integrate this part again. Alright, so now we have to integrate this part again to get our final answer. But one thing you will notice that if you integrate this one, it will keep repeating itself, right? So you can just leave this as your final answer, depending on the option. If the option has more than one, then you integrate this again. So let's just integrate this part, right? So we have the integral of ex cos x dx. So this one is our u and this is our dv. So our u is equals to ex e to the power of x, and our dv is equal to cos x dx. So here we're going to say du dx is equal to e to the power of x, and we have the integral of dv is equal to the integral of cos x dx, and here we have du is equal to ex dx, and v is equal to sine x, right? Sine x, right? So applying our formula, uv minus the integral of v du. So here we're going to have our u, which is e to the power of x, multiply our v, which is sine x, then minus the integral of v, which is sine x, then du is what? Ex dx. So this is going to give us ex e to the power of x sine x minus the integral of ex e to the power of x sine x dx. So now we're going to join it, replace it for this one. So we have minus e to the power of x cos x plus e to the power of x sine x minus the integral of e to the power of x sine x dx. So now you can see that this one is the original question, which is this. So if you continue, you just continue repeating and it will never end, right? So basically you can just leave it at this point at your answer, Jerry. So you leave this one as your answer. But if the option has more than just 1, 2, you can continue to as many as the option has, and then you stop. Let me just see this one will be faster. Trying to clear this area. It's not working. Alright, so let's take a few more questions. Alright, so I have this question here. The integral of natural log of x dx, right? So we have this. So what do we do here? So in this case now, this natural log of x here is going to be our u, while the x is going to be our dv, right? Because you know from the other ones that we did, like when we did x e to the power of x dx, this one was our u, but everything here was our dv. So now that there is nothing here, only the dx is going to be our dv, right? So we have u is equal to natural log of x, and we have the dv to be equal to dx. Then we take the derivative of du dx, and this is going to give us 1 over x, and then we take the integral of dv and the integral of dx. So here now we make du subject of the relation, so this is going to be dx over x, and then this will be v is equal to x, right? Because when you find the derivative, because just like you have 1 now, when you find the integral of 1, you just get that you just get x, but this one now we're having dv, so that's why we get v for this side, right? So now we have this, so we just apply our formula, uv minus the integral of v du, right? So our u is what? Natural log of x, our v is what? X, then minus the integral v is x, then du is what? Dx over x. X will cancel out x. So here we have x natural log of x minus the integral of dx. So here we have x being x minus the integral of this is just going to give us x, then we have plus c. Here we can factorize x out, so we have natural log of x minus 1 plus c. So these are our final answer. So very, very simple stuff. Let me see if I can take one more question. Alright, so we have the integral of x e raised to the power 2x dx. Sorry. this is 2x dx. So we have this, right? So we have this. Now you might be thinking that you use substitution for this and it will work. It's not going to work. Now this is the reason, right? If you substitute, what do you substitute for? 2x, right? So you say u is equals to 2x, right? And you say du dx, and then you get 2, right? And then you make the x subject of the relation. So you have du over 2. So now if you now try to put it back, where you have the integral of x, you have e to the power of u, then du over 2. It still does not work because of this x that is here. So you cannot substitute this. It does not work, right? So that's how you know if substitution will not work, right? You know it's not going to work. But assuming this was x squared, it is going to work, right? Assuming it was x squared, let's say we had x squared here. Let's say you have x e raised to the power x squared. Now when you take u equals to x squared and you take du dx, and this gives us 2x, right? It gives us 2x. Now we can say that the x is equal to du over 2x. Now when you put it back, x e raised to the power of u multiplied by du over 2x, this x will cancel out this x, so we don't have any x again, right? So now we have the integral of 1 over 2 e to the power of u du. This u, sorry, then this 1 over 2 can come outside, so we have 1 over 2 the integral of e raised by u du. Then this will now eventually become 1 over 2. Then we have the integral of e raised by u is still e raised by u. Then we have plus c. So you go be having e raised by u over 2 plus c. Then your final answer, because we're going to replace this u with x squared. So e raised by x squared over 2 plus c. So you can see it's very, very simple. So this one is substitution, right? So these are cases where substitution will work and where by part works, right? The only issue is that you might not have time to be able to explore all these options, but just looking at it, you already know that once you find the derivative of 2x, you will not be getting x that will be able to cancel out this x that was here before, right? And since you will not be getting that, there is no need for you to just waste your time doing integration by substitution. So you just go for integration by parts. Alright, let me see. Okay, so I have this question here. This will be the last question for integration by parts. So here we have the integral of x cubed natural log of x dx. So here now, for this one now, right, we are going to be making natural log of x to be our u. We're going to be making this to be our u, and this to going to be our dv in conjunction with this. Right? So now we have natural log of x. So u to be equal to natural log of x and dv to be equal to x cubed dx. So here now we have differentiate. So we have du dx, right? So we have 1 over x, and here we're going to integrate. Dv equals to integral of x cubed dx. So here we have du is equal to the x over x, and here we have v equals to x to the power of 4 over 4, right? Yeah, we have this. And so from here now, we're going to apply our formula uv minus the integral of v du. So our u is what? Natural log of x. Then our v is what? X to the power of 4 over 4. Then minus the integral of v, which is x to the power of 4 over 4. Then our du is what? Dx over x. 1x will cancel this, so we have x cubed left. So here we have x to the power of 4 over 4 natural log of x minus the integral of x cubed over 4 dx. So here we have x to the power of 4 over 4 natural log of x minus, here we can factorize 1 over 4 out, the natural log of x, the integral of x cubed dx, right? So this will now eventually be x to the power of 4 over 4 multiplied by natural log of x minus 1 over 4. The integral of x cubed is x to the power of 4 over 4. Then we have plus c, right? So what is common between these two is x to the power of 4 over 4. So we have x to the power of 4 over 4 into the bracket of natural log of x minus 1 over 4, then everything plus c. So this is your final answer, or this depending on what you see in the options. So I would So you can go and practice more questions just to make sure that yes, you have gotten it. So just practice more questions on this to make sure that you are strong in it. Just look for more questions, maybe in the manual to practice.